Okay, welcome to 3.3, page 4. Back on page 3, we had one theme, and what we were doing is we were taking logarithms of arguments that could be simplified and breaking apart and trying to get more simple arguments. Instead of an x, y, z, I get multiple logarithms, but the payoff is I get simpler arguments. And that's a useful thing for us at times, but it's also useful to do exactly the opposite of that. So use the property of logarithms to condense the expression. And I will say where the lead coefficient is 1. So ln of a sum, I can smash those together as a product. This is just ln y z. And that is it. This is simple log base 5, or 1 log base 5 of 8 on t. Now the common mistake, so don't write this down, that people make on this is they say, oh, that's log base 5 of 8 on log base 5 of t. No, it is not. It's log of, see that rule, I understand where it comes from, but that rule doesn't turn log base a of u minus log base a of v into log over log. It's just single log of the quotient. Okay, let's see. So I want lead coefficient of 1. I can't distribute this and make this log base 7 of z minus log base 7 of 4. I don't have a rule like that. Yes, I have a log minus log here, but that goes with a quotient. I can't distribute that. So all I can do is this. Log base 7 of z minus 4 to the 5 halves. See, the first thing that I want to see in your solutions is an L in your log, either ln or L. Okay, so this one would become ln x squared plus ln x plus 1. We have no rule for dealing with that x plus 1. However, ln plus ln is ln of a product. So the first thing I see is plain old ln, and I only have one ln. Okay, I think you can see where maybe we can get quick and do these if we know our properties. This 2 can come in as an exponent. This subtraction gives me ln of a quotient, x on x plus 2 squared. Highly encourage you. Try 80 if you're following with me here. I think 80 you might be done now. Single ln, the 3 comes in, x to the 3rd. The 2 comes in, y squared. That's a product. However, minus, that's a quotient. The 4 comes in, z to the 4th. Now, I would even encourage on 82, 84, try them in one step, but I'm going to do a couple steps here. I'm going to distribute this 4. 4 ln z is ln z to the 4th, plus 4 ln z plus 5 is ln z plus 5 to the 4th, minus 2 ln z is minus ln z minus 5 squared. And now I have a sum, so 1 big ln z to the 4th, z plus 5 to the 4th, all on z minus 5 squared. That's a minus. Now, understand the book might have this as 1 big ln. They might have it as z times z plus 5 to the 4th, all to the 4th like that. They might have it that way over, but this is fine. And try 84 one step. This 2 distributes ln x squared. So that is ln. I've got some minuses, so I'm going to put this up top. Minus 2, that goes in the denominator. That 2 comes up here. So because it's minus, we go denominator, x plus 1 squared. Because this one's minus, it goes in the denominator. Bring the 2 in as an exponent. Take a good look at that, see if that makes sense. Anything that's a plus, any ln that's a plus ln, goes, its argument goes numerator. Anything that's a minus in there, when we smash them together, its argument goes denominator. And that is it. The answer key might just have this: x on x plus 1, x minus 2, all of that squared. Might be like that. Kind of simplified, it's kind of in the eye of the beholder here. So another fairly short, there's a 6-minute video, but let me know what I can help you with. Oh, by the way, take a look at this one right here, warning. That factors, that matters. You're going to want to factor that into x plus 1, x minus 1, because then we can separate that out a little bit more. So that is a little sneaky one there for us. So there may be some discussion necessary for that, but I'd like you to try it. Okay, let me know.